HVAC with Stephen Rardon is sponsored by TrueTech Tools. Quality tools, essential support. TrueTechTools.com.
And we're off. Good morning, YouTube. It is October 12, 2017. Got a little project to get into this morning. Going back to Jason K, the star of the Real Customer video that I had posted a while back. We're going to do his heat maintenance. It was something like 88 degrees or something when I was there for his zone damper issue, and just wanted to have a little bit of a chill. So we're hitting go on HouseCall Pro, and one of these days I'm gonna set up so that I can actually give you a screen capture of this while I'm in the truck. I think it'd be unwise to try to do it with the camera in front of the phone, so we're gonna hope that we can do a screen capture one day or here at some point. And I really don't want to share my customers' personal information on the internet right now, so maybe we'll do a call for a business that already has their location advertised on the internet, and that way you guys can see how it works and how it integrates, and pricing and billing and all that good stuff. But I've been very happy with the utility of HouseCall Pro. It has worked very well, and I'm excited to share it with you guys as things progress. Anyway, we're headed over to do a heat maintenance. Stay tuned. Here is the furnace that we saw part of on the video from the other day with the zone damper repair. I don't remember what date that was set, but I have been here before, done combustion testing, actually replaced an inducer motor assembly, and trying to read the date here, I think it was February 18, 2015. The tape on that coil access door was installed. Just for fun, I think I'll probably take that off and check the evaporator coil again. Generally speaking, it is not terrible, and so it's not something I check every time, but it has been a few years. Obviously, it is 2017, and that was 2015. So, they do have a zone system. Got a Honeywell 322 with a wireless remote thermostat, and then 2 wired thermostats. The bypass is dampered, barometric dampered on the return side of the system, and don't remember offhand, but I'm pretty sure that when I had done all of the static pressure testing initially, that damper does flutter a little bit when the zones start cycling off. Don't think we're going to get into that for today, but yeah, the leaving air sensor over here is not in a location that I'm in love with, but it has been that way for several years, since 2006, and the customer is generally satisfied with the way that the system operates with it in that position. And since my plenum is all of 30 inches or so, I don't have a whole lot of space to put that somewhere else. But ultimately I like to have it down farther on the supply plenum. So I'm gonna get the camera in a static position and we'll dig into this sucker. I think that perspective will work for the time being. I'm going to go ahead and fire up the iConnect and place my air probes for that. Return sensor and supply sensor goes over here. Now, I do have a bit of an issue with how Trane does their blower cabinet on these downflows. Obviously, if you have to get your vent pipes out the top or the bottom of the unit, depending on which way you're oriented, it is nearly impossible to do anything different. But this is a blower capacitor, or a PSC blower motor, and as a PSC motor, there's a capacitor behind that wall. But to get to that capacitor, you would have to remove all of this piping, the black pipe, as well as the white pipe here, as well as the circuit board. And so, as much as I don't like to, since I didn't set this system up, I would generally not relocate that capacitor until there seems to be some need for it. If the blower quits, then obviously there would be a need to get to that capacitor, and at that point, if I were to replace the capacitor, I would actually bring it to the front of this panel. And I know that I've had commentary regarding the fact that that's not a great idea, because then you destroy the UL listing of the system. But when you think that that capacitor should be checked and it's not accessible, most people are going to not check it. We'll start off by checking the flame sensor. My go-to meter for the quick basic checks is the Testo 770-3. It auto ranges for a lot of things, so it makes it simple to just turn it on and get your readings for resistance. And this flame sensor is showing a resistance of 15 ohms. Generally speaking, that is good for this type of flame generator, hot surface igniter. But I always have to clean the burners, and if I'm going to have to clean the burners anyway, I'm going to have to disassemble and look at the burners and the heat exchanger from the burner access. Don't think you can see that very well, but it has some buildup on it, but not so much that I'm concerned with its expected longevity. I do know that the warranty on this system is now expired on basic components. We replaced, what was it? I think we replaced the pressure switch. And before we replaced it, we were pretty sure that there was still a warranty. But when we went to get our warranty replacement, they told us that the warranty was indeed expired. So other than the heat exchanger, I'm pretty sure we don't have any warranty left. Flame sensor looks kind of grody. Once again, you probably can't see it very well, but we're taking the soft bristle brush and taking the buildup off of the flame sensor. You want to do it gently and use a soft bristle brush. Brass bristles work nicely, though I couldn't find those, so this one's, you know, I don't know, wire bristle. It's soft and I'm not hitting it real hard to damage anything. I'm going to pull the burners next. Always a bit of an aggravation when they like to fall down, but without making sure that they're clean, you are just guessing. I did turn the power off. I don't need it trying to fire the heat while I'm playing with the gas side of the system. Burner looks pretty good. Really can't complain, but always just give it a offhand scratching just to make sure that the crossover tubes or channels are not obstructed in any way. So we're doing pretty good there. This headlamp is back in action right now, but the elastic strap is kind of worn out, so I'll probably be looking for a replacement. When the inducer assembly was condemned several years ago, they actually claimed that there was a crack in the heat exchanger and that they needed to replace the system. And I don't feel like that is the case. After all of the testing that I did, I could not find any evidence of a crack in the heat exchanger, though I am kind of intrigued. Let me see if I can get a view of this for you. Somehow, those screws, see if I can point to them. That screw, and then up here at the top, there's another screw that is loose. And I do not recall having seen that. And I can't imagine how that might have happened. I'm going to see if I can get a drill chuck on there and tighten those screws down. That's bothersome that it either somebody loosened them or somehow they became loose on their own, and I can't imagine that there's nearly enough vibration to do that. It just seems unlikely. But with as easy as they are to access with the burners out, it wouldn't surprise me if someone did at one point take them loose. But despite the fact that they're loose, they have not shown any indication of affecting combustion or indicating a potential crack in the heat exchanger. Looks like we got lucky this time. A lot of times the burners will try to fall out as you're putting them in when they're assembled in a vertical manner like this. All right. flame sensor back in there. That can also be sometimes difficult because the flame sensor is not easily accessible to hold it still while you're trying to get it back into the position where the screw will hold it down. Maybe I shouldn't clean these at all, but it seems like any resistance that may be added by collection on the burner is a good thing to get rid of, or the igniter. You want to be careful when you're mounting your igniter with a impact driver, especially, not to impact the screws to the point where you could crack the igniter. I have put in brand new igniters and the screw didn't thread smoothly and broken brand new igniters right off the bat. Let's shut the gas off and get ready to take gas pressure here with the gas valve. I'm trying to remember what, I think it's a White Rogers gas valve. You don't have to remove the screw completely. You can loosen it a few turns and generally get the manometer to take a reading of the gas pressure by just loosening it. They have the smaller, I don't know, 1/8 inch screws rather than the large plugs that you would use your service wrench to remove. They can be very easy to lose, and you don't want to lose them. So you can just back them out a little bit. Looks like I need to return old school Eddie's little mirror to him. I guess I've had it for quite some time. I haven't seen him in a while. One of the fittings that comes, I think it's with the Fieldpiece manometers, but sometimes with your propane conversion kits you'll also get this larger tube adapter that will allow you to slide the rubber over top of the fitting. The hose pieces that come with the testo manometers can also work some of the larger pieces of hosing, but they can be kind of aggravating to try to stretch to get over top of those fittings, so the adapter makes it very easy. See if I can find my other adapter before I fight with it too much here. I must have pulled it out of the location that it normally sits and it fell down to the bottom. So I've got 2 adapters to get my gas pressure off of that manometer, and then just use the standard, I think this is also 1/8 inch hose that I use for the other ones. Just pull the other threaded fittings off. That is incoming, that is outlet. Okay, as usual, the 2 510Is. They're going to lay off to the side for now. While that app is booting up, I'll get set to test the flame sensor. Since this is a closed burner box, I will get the flame sensor signal first and then close the box once the flame signal is recorded so that we can do combustion. probably don't put that behind me because I'm going to have to move myself around here. Always fun to try to get to that stake on tip. So we're going to clear, zero the pressure sensor for the 510i manometers, and then we will connect them. Just make sure we've got outlet on the blue gauge and inlet gas pressure on the red gauge. The importance of checking outlet and inlet pressure for gas is mostly just to confirm that the gas pressure, at least for me, mostly just to confirm that the gas pressure incoming is sufficient. I'm already checking gas pressure. I might as well check both when they are reasonably accessible. Alright, so we're ready for flame signal. Gas pressure. And I will be right back. So I decided to pick up a third 510i for the fact that if you're trying to do testing during operation, a lot of times you need more tools, which my wife hates to hear, but I'm going to zero all three of them here, but got the third one. Need to change the edit view. Last one is showing M bar. I'm going to change it to inches of water, and then I need to clear all three of them back to zero so that they're all reading the same. So we got incoming gas pressure, outlet gas pressure, and then I picked up some vacuum tees from the auto parts store for doing tests exactly like this. So I can tee into the inducer motor pressure switch, and then since that's going to be pulling a negative pressure, we're putting that on negative pressure port for the manometer. Alright, so we're going to fire it, get a flame signal, and then once we've got a flame signal, we'll close the burner box and fire the system for combustion. We'll go ahead and get combustion set up before we go that far. I had a socket nut driver that would fit that plug, which is basically just an orifice with no hole in it, a burner orifice. So with the Testo 330i, there is no display. It is just like all the other displayless accessories available today, but it is basically just a Testo 330 rebuilt for Bluetooth communications. Let's see if I can get my adapter cone threaded in. And it looks like I need to hold my mouth just right to do that again. Either that or this hole was for my old 320. But I think we should be able to get it to work. So it looks like I'm going to have to open that hole up a little bit. Alright, we've got it in. We've got a small port here for testing intake air down there on the return side. I guess you could see that already. At this point, we don't have to test combustion air inlet at that point because the combustion pulls from the crawl space. But if we were dealing with a two-pipe system that took both intake and exhaust from outside, or from and to outside, then we'd want to test both. Alright, power is back on. Override purge. And I'm going to disconnect the zone damper common on all the zone dampers so that I can just run the thermostats from the zone board by jumping out one thermostat. Alright. We'll get flame sensor. Alright. So inlet is 6.7, outlet is 3.8, and the manometer is running a negative 1.8. Flame signal is 2.4. Pull the flame sensor out, plug it back while we put the burner door back on. The combustion is coming on my phone this time so that I don't have the issues that I had walking away, and I can just jump back and forth between the Testo combustion and the Testo smart probes. So smart probes are running there, 3 smart probes, and then combustion is running there. We're going to let it balance out for a while, monitor the air temperatures, and we'll clock the meter. One of the stipulations that iManifold software dictates is that you maintain liquid line temperature before you're going to get the balanced system indicator, which is a green check mark right there. So I've got my liquid line temperature and my liquid pressure probe, high pressure probe, connected. Even though it's not necessary, it will give me that check mark on and let me know when the airflow is balanced out without having to actually go check the numbers and see if the temperature is balanced. The numbers as they are now for combustion are 90.4 degrees or percent efficient, 118 stack temperature, CO2 at 6.4, O2 at 9.5, COPPM at 19, excess air is 73.9. We've got the system maxed out on the manufacturer's recommended gas pressure. So that's partly why we're not getting a better excess air temperature. If we had more gas pressure or slightly larger orifices, we could get excess air down just a little bit. But at maximum recommended gas pressure, you'd have to do some modification to get more out of it. Right now we are getting a 44 degree temperature rise. It's not necessarily slowly creeping up, but it is still balancing. And the allowable temperature rise is 35 to 65. Let's just check on our Testo smart probes or manometers again. We've got 3.75, 6.84, and 1.73. Those numbers are probably creeping a little bit because they tend to, but they're reasonably close to what I would expect at this point. To sort of show that, I will disconnect the outlet gas pressure while I'm pinching the hose and show you that we've got a creep of about negative 0.01 and it moves to about 0.02, so it's creeping slightly from where it was zeroed initially. And just to show you the stability monitor there, it says liquid line is stable, and now we're just waiting for temperature split. Now, just for instance, if I was trying to troubleshoot a flame sensor potential issue, I would leave that burner box open so that I could maintain my meter connections and be able to monitor what the flame sensor does over time. But generally speaking, as long as you're not experiencing an issue, you don't need to concern yourself with monitoring the flame sensor over time. It looks like we're actually double trapping this drain on the furnace a little bit. When this elbow sags down, it leaks water back here where the hose clamp is connected. Alright, we've got balanced temperature at 49 degrees. I'm going to go clock the meter, and I'm not going to take you with me on this one. If you'd like to see that happen, I've got several videos that posted recently. We're going to capture the measurements for I-manifold, and then also capture the measurements for combustion, and then we'll export those. Well, no job is complete until the paperwork is done, but you can't do paperwork until you put everything away. So we're gonna pack everything up. I did say that I was gonna check the evaporator coil. Be noisy, but I'll show it to you. So you can see that the coil is clean. I'm gonna have to go get some tape so I can seal this back up again. I think that turned out pretty well. Just want to notate, because I've had questions about the time it takes me to do the testing. I got here about 8:15 and it is 9:40. So between cleanup and everything, just about an hour and a half. So you can do it. You just need to become proficient with your tools. If you're new to the game, it really doesn't hurt to, take your time and learn the process before you get speed. if you're aiming for speed right off the bat, I think it will be deficient. You will end up making poor decisions if you focus on speed before you aim for excellence. I'm definitely not the fastest or even the best, but I do my best to do things properly as well as I know how, and you will develop speed over time. So I'll get off my soapbox and close this one up for now. Thanks for watching. Like, subscribe, comment, and share. And don't forget you can use coupon code RARDON at TrueTechTools.com to save 7% on your purchase. We'll see you on the next one. Peace.